this part, this is the 1.5 inch compressor pin, and basically, you draw the part up, and I did a couple of extra things this time. You have to be kind of flexible working on a CAD cam, because sometimes you think you just draw a part up and create toolpaths, and you'll have other issues that come up. Depending on the future geometry, when you assign a toolpath off of it, it may not, the software may not want to assign a toolpath. The software is not a mind reader; it doesn't really know what you're trying to do. So there's limitations, and you're driving toolpaths off of features. Okay, now depending on the feature and the type of toolpath you use, it may just not give you a toolpath, because there may be some kind of conflict in the way you're doing things and the way the software works. So there is some limitations, and you have to be able to get around those limitations, because it doesn't matter what software you're using, you're going to have problems. So here's the model right here, and we have 3 operations. So we have 2 lathe operations and a mill operation. Okay. So here's the first operation, and basically what's going on is you come in, you face the part, you turn the OD, and if you notice, I'm only turning the OD to here. Let's see, if I turn this to that isometric view, you can see what's going on. So it's cutting the chamfer on, and that's all, right? That's because we're using 1.5 inch stock material, and this OD is already 1.5, so there's nothing to cut along this OD except the flats and the chamfer on each side, right? So that's the first operation, and then the part gets flipped over in the lathe. And typically how you would run this is, it really depends on how many parts you have. If you're just running one, you would just run that one part, flip it over, and do the other side. If you're running 10 parts, 20, 100, you're going to do things, different. Depending on the part process, and I don't know, sometimes you can speed things up. Sometimes it makes sense to do things a little bit different. If you're running 1,000 parts versus one. Like when I'm running one part, sometimes if it's just a part like this and I just got to make one, sometimes I won't even write a program for it. I'll just hand type it some G code. I made some, I call them G code templates, and basically they're on the machine. Like the first 5 programs on the lathe, one's a stock out program, and basically all it does is it moves the tool over and it stops with M00, and then ideally what you do is you pull the material out against the stop, and you retighten the chuck down, and when you hit cycle start, and the spindle doesn't turn on or nothing, it just backs up and moves out of the way. And then my program number 2 is a face. All it does is come in face, and it uses the can cycle. So if I have to face off a 1/4 inch versus 50 thousandths, I just change the Z starting place, and it'll take 10 passes or 1, depending on what that starting place is compared to the Z ending position, which is Z0. Then I have a turning template, which is just a can cycle. It's a G71, and basically I have all these templates on there. So sometimes it makes sense for me just to copy and paste a G-code script, and just change the starting and ending positions, because I can literally do that faster than jumping on the CAD cam and drawing the part, and doing the setup and creating the toolpaths and posting the code and saving it to the USB stick and putting it on the machine, all that. if it's just one simple part with a couple of turned ODs, I don't even write a program, or I'll just handwrite one. So it depending on how many parts and complexity of the toolpaths, sometimes it makes sense to write a program, sometimes it doesn't. Sometimes you could just take a existing program of a similar part and just modify a couple things, like if you're just turning to OD, in the existing parts going back 1 inch and this one's 1.68, you just change the Z depth and the X starting position and ending position. But anyways, so that was op 1 there, and op 2 looks like this. So the part gets flipped over, and it comes in and cuts this side. So that's op 2. And then you have the mill op. And the mill op is, I'm just using a 2D contour. Now the mill op looks funny with the stock. Now, if it's worth the investment of time, like this stock, it looks funny on the simulation, but the code it's giving me is fine. It's giving me code to cut these parts right here. And if I simulate it, it's gonna look something like this. And just looking at this, I could have shortened that up. I'll show you what I mean. So the flat only goes, it's only 1 inch long, right? But my lead in and lead out is kind of exaggerated. Let's see. So I could probably change these lead in and lead outs and make them where they're not as far. See, right now I have a 1/2 inch. I could put that 0.25. Let's see what it does. See, the tool's going all the way over to the right, so that would make your cycle time take longer. In some cases, if it's worth the investment of time, what you could do is actually import the stock in, and let me show you how it's done. I'm not going to have y'all do that yet. Like this is totally acceptable, but there's limitations to it. Okay, if I have a bunch of parts to run, if I'm running like 500 of these parts, I want to get that cycle. I want to save every second I can of the cycle time, because it's going to add up over a bunch of parts. So what we want to do is decrease this lead in and make it basically drop the end mill down right in front of the part. So as soon as it moves in, it starts cutting. So you're not. It's called cutting air. That's what machinists call it. Basically, when the tool's coming down and it's just feeding into the part, but it's not actually cutting material yet, it's called air passes or cutting air. Okay, and shop supervisors and production managers can't stand cutting air. So you're actually gonna get a job running a program or as a machinist. You want to decrease. You always want to. You don't want to be cutting air, okay? Unless you're doing the initial setup, the first piece, and you're testing out, make sure, try and prevent any crashes. Yeah, cutting air is no problem in that scenario. But having every part where the tool's coming in and it's cutting air, it's gonna decrease cycle time. I'm sorry, it's gonna increase your cycle time. And if you're trying to look good in front of your boss, which you should, because that's how you get raises and and move up in an organization, is I guess you got to think like you want to be as valuable to the company as possible. You want to make sure that you add so much value that you know, when it comes to layoffs or they have to make important decisions that, you know, that they don't want to lose you, you know, or it may pay you more too, because there's always job offers. You know, there's a lot. There's a lot of machine shop managers or production managers. They'll talk about, you know, they don't want to hire a guy and then he leaves for another job up the road. You know, for $1 more an hour. You know. But anyways, so there is some flaws of this, and one thing that's causing these flaws is I'm using the same 2D contour to do both sides. Okay, now the problem with that is, well, there may not be a problem with that. So sometimes it makes sense to actually use a 2D contour for each one of these flats, you know, because you can go into the settings and you have more control over your toolpath, basically. If I simulate this, notice on one side, okay, so notice on this side, it starts over here, okay? So it's starting to the left. Now on this side, it's starting to the right. Now the reason why it's doing that is because in the settings, I have it on climb milling. Okay, usually on a CNC, you're gonna put like almost every, you know, anytime you use an end mill, you're pretty much always gonna have it on climb milling. Well, actually, it's not conventional milling. Let's see. I think I had problems with climb milling. Okay, well, it's not climb milling now, but we're still gonna have the same problem. On one side, it's gonna start on the left, and the other side is gonna start on the right. Okay, so this side is starting on the left. Okay, so okay, so what is doing this? So you see how the blue line goes to the right? It's going pretty far, but the flat ends, you know, right here. So and also, if I was to really make this part for a customer, I would definitely change some stuff. Like the radius right here, that's kind of a big radius. Like that would, it doesn't look bad, but you know, when you compare the part to the print, it does look a little funny. One thing you could do is come back and finish it with a smaller end mill, which would make that radius a little smaller. Let's see. Okay, so let's talk about this stock. So the way I set this up was, and this is the easy way, is just to tell the software, you know, just use relative size cylinder and put your radial and your radial offset at 0. And what that does is it makes the stock no longer than the part is and no larger than the largest diameter. Okay, that's just the quick, easy way. You know, it takes like 5 seconds to do. Now, if you were to really, you know, if you were to actually make these parts and you had to make more than one, or you had to make, you know, enough of them where it was really worth the time to get everything exactly the way you wanted it, what I would do is I would duplicate this file. So we already wrote the program. I would go to File, Save As, and I would make a copy of this and call it stock mill. Okay. Now you don't have to do this. This is just another option. Now we are going to have assignments where, you know, you will make your own stock file, which I'll probably give y'all a blueprint for the stock. But this is what I would do. So if I was wanting to create the stock, I would come in here and I would delete this flat. Then I would come over here and I'm just selecting it and on the keyboard hitting delete. Okay, and I would save it. Okay, so I'm gonna close this file back out. And reopen the original file. And if you see, I got two of them now on my recent data. I have the 1.5 inch compressor pin stock mill and the 1.5 inch compressor pin, right? So I'm gonna reopen this. And I'm gonna switch back to design mode. And I'm going to drag it. So I'm going to click on this one. It's called stock mill. And I'm just going to click on it and hold it and drag it over to my workspace. Okay. Now, because this was creating the same, like basically a duplicate file, the orientation and everything is exactly the same. So I don't have to move it into the right position. I can literally hit OK. And what you're seeing now is you're seeing two models on top of each other. Okay, if I go to my browser right here, I have two files. I have this compressor pin, well, or the original file right here, and then I have the stock, and I can hide it. So I'm gonna go ahead and hide that, and I can hide the 2D sketch lines. Oh, that's my problem right there. So my sketch lines are really long. Okay, the reason why I did that was I can actually turn my lead in and lead out off and just tell it to start here. I probably said that in the video, but okay. So I have two models on top here. I can hide these sketch lines. So I'm gonna go back to manufacturing mode and back to the mill op setup, and let's see. Okay, you know what? Temporarily, I'm going to go back to design mode. Okay, so this is my stock mill. So I'm gonna show that, and then I'm gonna go to manufacturer, and on the mill op, I'm gonna right click and go to edit, and on the stock, you have this. So if you click on your stock mode, instead of rail type cylinder, I can make the stock from the solid. Okay, so I'm gonna choose from solid. And now it's going to want me to choose that solid. Okay, so I'm going to click on it right here, and I'm going to click on the stock. Okay, and sometimes it won't want to click on the stock, like it'll select the wrong model, because what you're looking at, you're looking at two models stacked on top of each other. Okay, because they're in the same orientation and XYZ position, it looks like one model, but it's actually two models. And you can see as I move my cursor, see how it toggles between each model. So one thing I could do when I go to select stock, I could, if you're ever having trouble selecting the right model, you could actually go over here to where you have models. Why isn't it showing up? Here we go. So I got that. This is the compressor pin. Okay, I need to update Fusion on this. For some reason, this copy on my laptop is a previous update from last semester, and it was like the major update, and they kind of screwed up some stuff. The model I'm looking for is actually not showing up. Well, I'm in manufacturer mode, is not showing up, but it doesn't matter. I can see the model I need, which is going to be this one. So I'm going to click OK. And you shouldn't have to, yours should be simpler. So I'm going to go, man, I don't know if it's because my browser, it's the settings. Okay, that's it right there. Side this. Okay, it's right there. Okay, so if you're looking here, at the very top it has the compressor pin, and then right here it has the compressor pin stock. So I gotta hide that because I don't need that anymore. It's just more of a, I'm just using that second model as a tool. Alright, so we'll go back to manufacturer mode. And so everything looks fine now. Okay, hit save. Okay, so everything looks good. But now, my fusions, it's going to want me to regenerate it. So I'm going to regenerate these toolpaths. Okay, so now, when I simulate it, it's actually going to show what the stock currently looks like, okay? And you can see, you know, the stock is exactly the same, except it doesn't have the flats on it, right? So when I simulate it, okay. Anyways, yes. But oh no, it doesn't matter because you gotta think the actual part. You know, you can just rotate 9 degrees and it's the right orientation. As long as these two slots are parallel to each other, it's fine on this part. You know, now if there was like a hole right here, and the hole had to be perpendicular to the flat, yeah, in that case it would matter. But there isn't any other features that relate to the flats, and that would be milled, so it doesn't matter. And let's see, I'm gonna go back to design mode. Oops. So what I did different on this part was, you know, I had trouble getting the right toolpath I wanted, so I sketched up these two lines, or well, I guess 4 lines, and these are what's actually driving my toolpath. Now I could make these lines shorter. The reason why I gave them that length was good. And I like to name these too. I'm gonna name these flat toolpath lines. I mean, it doesn't really matter what you name it. I'm just naming that so when I'm going through everything, I know what's what. Okay, so I made these lines. I extended them out, I think 0.35. And the reason why I did that was, you know, you're using a 1/2 inch end mill, okay? So you got to think the toolpaths are driven based off the center of that end mill. So anytime the software does any kind of compensation of an end mill, is compensating the radius. So if the toolpath is driven from the center of your part and it compensates radially, so you're using a 1/2 inch end mill, your radius is going to be 0.25, right? And anytime you drop a tool in front of a part, or you know, and when you go to lead in and cut, you want to give yourself some kind of clearance. You know, you don't want to drop the tool on top of the part because it's gonna your tools can wear out faster. It's just not proper. You want to drop it in, then feed in. And usually, you know, as a rule of thumb, most machinists just add an extra 100,000s just because it's a low but simple number. So anytime you're doing math or editing code on the machine, you know, you can easily add 100,000s. Now, in, you know, outside the U.S. where everything's in metric, you know, they usually just add a millimeter, like 1 millimeter. That's because, you know, it's such a small amount. You know, if there's a little bit extra, like wasted feed time, it's not really going to make a difference. You know, you're talking about like, you know, half a second. A half second is not really going to make a big difference on cycle time unless you're running, you know, 10,000 parts and the parts take 30 seconds, you know, per part to make, which sometimes they do. I mean, I ran parts to take 10 seconds to make. Now, you know, we only got like 25 cents per part, but you know, your machine time per hour goes up. But anyways, it's just an easy number to, you know, 100,000. You know, drop in you know, the radius. What you want to do is get the radius of the cutting tool and add 100,000s to it. So, because I drew in the lead in and lead out like distance and clearance into the line, what I could do is just go over here and turn my lead in and lead out off. And now it's gonna I don't really like that. If you look at this, it's actually coming down on the part. Let's see, let's simulate it. So this bottom toolpath's not bad, but the top one, you see this right here? See, that's going to be a problem. I mean, that would work, but it's just not like a good toolpath. You want to have some kind of clearance. So, I mean, I could add a little bit of clearance. The easy thing to do would be to add a little clearance in here. Into my lead in. So if I go to lead in, you know, I could, you know, add, we'll say 0.1. Now if I go to simulate it, now it looks like that. Or I could just go back into design mode, right click on the sketch, go to edit, and make this see, I did 0.35, but you got to think my math was based off you know, the radius of the cutter plus 100,000s, but I'm losing some of that distance from here to here. So I can make this 0.45. Go back to manufacturer, and I could take that lead in and lead out of here. The reason why I want to do that is because I'm using the 2D contour to do both sides. You know, I may, because it's climb milling, you know, one side is going to feed in from the left and feed toward the right, and the other side is going to feed in from the right to the left and then out. Okay, that's because it's climb milling. So climb milling is based off the direction of cut and the side of the feature, you know. So I don't know how well y'all can see this, but if, say that you gotta cut this part, right? If I cut here and they come over here and do the same thing, one side, this is conventional milling, and this side, it's climb milling. That's because climb milling or conventional milling is based off the direction of feed, which is based off the feature. You know, so the feature is pointing this way here, and this flat, you know, is this way, right? So if I was to climb mill, you know, it would be different directions. So on this side, it would start off here. If on this side, it would start and feed in. Okay. But climb milling is a better. You get better cuts. The end mill just performs better. And you're probably wondering why, you know, if it cuts better, climb milling, you know, why do they even have conventional milling? That brings us back to like different machines, you know. Manual. So climb milling, the cutter basically removes the shavings away from the cutting zone as the end mill feeds in, and it kind of climbs up the part. Okay. In conventional milling, it doesn't do that. But climb milling, because it's kind of climbing up the part, if you don't have a strong machine, what can happen is, because the cutter's cutting like, let's see, because the cutter's cutting like, let's see, it'd actually be on this side. Because the cutter's cutting like this, it adds more force applied to the part. So if you have a machine that, we'll say, not rigid, like, you know, you got little bitty motors on it and it's kind of underpowered, it would basically, the force, it adds more cutting force, so it could actually pull the part out. Okay, now with that said, in manuals, like a Bridgeport manual mill, you don't climb mill. As a rule of thumb on manuals, you don't climb mill at all, because there's most of the time you don't have a motor actually driving the axis. You know, you're just manually turning it. Basically, when that force is applied to the workpiece, it'll actually start feeding itself. Okay, it'll actually you'll go ahead, you'll be turning, you know, the handle and kind of feeding into the part. And then all of a sudden, once that force starts pulling on the workpiece, it'll actually pull the part down. Okay, or basically what will happen is you'll start seeing the handle move by itself. Okay, which if you're going at high RPM or a really high feed rate, the part can get away from you and you could junk apart, or it could turn into a dangerous scenario. Now, what we do at the school, you know, we do light machining, so y'all wouldn't really have to worry about that. But, you know, if you're cutting like hard steel, and you know, it could turn into an abusive scenario, or you're like abusing the machine or the workpiece. But anyways, so a lot of times, you know, you'll create a toolpath, and I couldn't get the toolpath I wanted, so I just drew the lines up here and drive the toolpath off of those lines. Okay, that's actually basic CAD CAM. If you were to draw this part up in Mastercam, dude, you'll see something like this in Mastercam or EdgeCam. Sometimes they won't even have the part right here. What they'll do, if I was to actually draw this in like basic CAD CAM, EdgeCam, Mastercam, and I didn't have like the 3D model upgrade, what you would see is you would see a drawing that would look like this. Okay, so now depending on who's drawing it up. You know, everybody has their own little style. You know, so you'll hear programmers and machinists argue all the time. Be like, don't do it that way, do it this way. You know, sometimes they're right, sometimes they're wrong. I mean, it just depends. But if you were to be writing a mill program in like Mastercam or EdgeCam or GibbsCam, and you didn't have the 3D model, because you got to think, there's a lot of programmers out there. They're basically old school machinists. You know, you'll see this in a lot of smaller shops. Basically, it's some old dude that started off machining with manual machines, you know, and he started his own company, and he got work, and the company grew and grew, and he was always a programmer, you know, and, you know, he may not have the best computer skills, and, you know, he just draws lines and drives toolpaths off lines, and you'll see something like this, where all it is a rectangle with 4 lines explaining the toolpath, or giving the driving factors for the toolpath. Like, this is what the program would look like. Okay, you may not even need that square right there. You know, so you'd see something like this. Total, I mean, dude, I've wrote programs where, okay, so this part right here, okay, so what I'm getting at is you don't really need a 3D model for the toolpaths. If I was to actually write a program for this part, I could literally draw a rectangle and a circle. Okay, so this is 1.8 by 1 3/4. So I could literally come over here, and draw a rectangle here, and let's see, so the toolpath is 0.54 from the side, or the cutout or flat, whatever you want to call it, 0.54. So I could literally come over here, take this line and copy and paste it, go minus 0.54, and then I need a circle, so we got 0.42, Yeah, okay, so it could be because you're using adaptive clearing. Adaptive clearing, oh, what is this part called? Advanced 201. Yeah. Hold on, I saved that to the wrong place. Okay, so this would actually be my drawing. Like you could literally draw this up. Now, if I went to manufacturing now and actually do my setup, let's see. we'll do a relative size box. Now the software doesn't know what Z or Z0 is, so I would want to do something like select my X and my Y. And we can flip to Z now. There we go. Okay, so this part is 0.623 tall, so okay. So this would be my part, right? And the origin being right there, you know, I can move the origin. Where's my edit? Oh. Alright, so I'd probably want to move my origin like right here. There we go. Usually you don't put the origin in the middle, unless you're running a symmetrical part where it makes sense. Okay, so what I could do is, you know, I won't do a face. We'll do a 2D contour. So the distance from here to here is 1.8. So I would use probably a 2D contour is probably the best way to go. So what tool? Garrett said to use a 3/8 mil. Is that the only tool y'all are gonna use? Yeah, he's probably gonna want the face mill to do that, because basically it would take forever to do a 3/8 mil, because that's quite a big of a distance. Anyway, so I'm gonna do is I'm gonna milling face. Yeah. Bryson, dude, I'm finally making that delivery day, man. As soon as I get out of class, man, I ran into some problems on the part. I got to see it's 3 pieces get assembled, and the second piece has this weird radius on there. And I've ran these parts many times, but because they changed the material to tool steel S7, and it's like way harder. When the tool there's like this radius chamfer thing on the front of the part where it kind of goes in and it makes a radius, but it's a 45-degree chamfer. Where it meets the intersection, it comes out. The tool chatters like crazy, man, and it has a half-inch. You're supposed to use a 1-inch tool to cut it, but all the 1-inch tools I use would chatter, and I had to get another tool, but there was problems with that tool because the chamfer has to be a half-inch, but the tool would only go. The inserts were only like 0.35, so I had to do this weird step down, like 45-degree step down. But then it was leaving lines where it didn't blend in, and dude, I sat like all weekend like editing code trying to make that toolpath better, and I finally got it, man. It actually wound up being easy when I figured out how to do it. That's how you learn, man. Is you get stuck on a job, you'll get stuck, and you'll spend like you'll work, you'll keep going and going, and like you'll try all kinds of stuff. You're like, okay, I'm gonna try this, oh, that didn't work, so you try a different tool path. Oh, that didn't work, and that's. Yeah. Yeah, it's definitely going to be beneficial, especially if we go over all the CAD CAM in this class, and then you'll actually run it in y'all's class. Dude, I'm gonna be honest, none of the other campuses are doing that. Yeah. Well, the CNC teachers don't coordinate with the CAD CAM teachers, and they all kind of do their own thing. But Garrett's really good at having y'all actually run the CNCs. The other campus teachers, basically, there'll be like the whole class. The teacher will be setting up the CNC, and then, like the whole class will be behind him, but you can't see nothing when it's like that. So you have no clue what's going on, and yeah. Guys, I lied. I said 3-inch end mill would be better to cut this little flat right here. I'm forgetting how small this part is. I mean, if you look at this, you don't really need to do that. But I'm gonna go ahead and show y'all since I already kind of drew that up. But yeah, it's a little bit too much. Okay, so we need to know our depth. Okay, so we got 0.623 minus 0.358. So we need to go 0.265 deep. Hold on. 265. Alright, so on my depth, my bottom height, I'm going to put it on absolute and go minus 0.265. Alright, so it's going to be a toolpath like this. If I simulate it, now this is taking it all in one pass. And if I wanted to, I could hide these 2D lines, You don't have to have them. Let's see. So I could actually hide that sketch. It would look something like this. Fusion 360 is all about these radius lead-ins, which they're good. I mean, that definitely works. But as a machinist, a lot of times you're gonna be at the machine editing code, and in that case, it's good to have 0-degree lead-ins. So what I would do, because I mean, if you're actually a good job as a programmer, there's a good chance you're not going to be writing the programs and running the parts, okay? Unless you work at a small shop. But if you have a shop bigger than a few people, more than a few people, there's a good chance if you're the programmer, you're going to be just writing programs, and the machine's going to run it. And if you're to have the radial lead-in, like the machinists are going to complain, especially the old school guys. They're going to be like, "What is this?" So you want to have like a straight lead-in. Okay, that's not quite straight. These radial lead-ins are good for tool life. So you'd have a lead-in that looks like this. So if I simulate it, now you're gonna have problems. See how it comes down on top of the part? Because I took the radius lead-in and changed it to 0, I would need to make sure that my lead-in distance right here is a good distance. So you got to think, if it's a 3-inch face cutter, I would need a lead-in at least a radius value of that. So 3 inches diameter, the radius value would be 1.5, right? Now you want to add an extra 100 thousandths for clearance, so you're not skimming the part as you go down. So I would go 1.6, and if I simulate this, it's going to look something like this. Let's see. And that's kind of a lot to take in one pass. So what I would do is I would have like multiple depths, say like 50,000. So it's going to take multiple passes. Oops. There you go. And if you notice my toolpath lines, I have green, blue, and yellow, okay, and red. The yellow is rapid moves. The green is lead in and lead out moves, and the blue is the actual cutting moves, okay. So the blue is where it would actually engage the part and start cutting. So I'm gonna re-simulate that. So if you look at it from the side, you can see the green is when it's leading out. Okay. So if I was wanting to get the green toolpath line smaller, I would change this lead-in value right here. So they're 1.6 long, and the blue is the actual cutting. A lot of the software doesn't decipher like cutting lead in, lead in, lead out. It usually just has like two color lines, like a rapid move and a feed move. Fusion has them separate because you can change like the cutting feed rate. This would be the blue line, so it's going to feed at 20 inches a minute, and your lead in and lead out, which would be the green colored toolpath line. I could change those feed rates. Okay, because if you're leading in or leading out, you're most likely not going to have any cutting force applied to the tool, or you're not going to have very much cutting force. So you could go faster on the lead in or lead out. Or if you're worried about having an interrupted cut and cutting too much when the tool enters the material and exits the cutting area, you could lower those feed rates. Plunge, it's not really touch anything, so I always put that at a higher value. Oh yeah. Especially since I made the line straight. Okay, so check this out. So I'm gonna post this code. Make sure I'm on milling. Hold on. It's not letting me do it. I'm trying to delete all of these. It won't let me do a select all. Oh, where is this? Local. Alright, let's see. I need to update this copy of Fusion. The reason why I'm doing this is because if I use a duplicate number, like a program number I've already used, for some reason on this version of Fusion, instead of overwriting the G-code script, it'll actually pull up the original G-code file that was named that program number, which is kind of annoying. But anyways, so here's my toolpath. It's pretty simple. X and Y moves are pretty simple. Okay, so we're going to keep that there. And what I'm going to do is I'm going to change it. I'm going to change my lead in and lead out. So I'm going to change it to that radius lead in and lead out. I'm going to show you what the difference is. So we'll... Okay, there is a radius here. Okay, so how about this? We'll just hit undo a bunch of times. I made a bunch of changes and I don't remember what it originally was. Alright, here we go. So this is what it originally was, right? We'll go ahead and do the same multiple depths at 0.05. Okay, so now if I post the code for this one, I'll make this 6. Okay, so I have 5 and 6. This one's with the radial lead-in. So it does a horizontal radius and a vertical radius by default. And this is the modified one, which I made it just straight, 0 degrees, okay? Alright, if you look at the code, look how much longer, there's a lot more code, but if you were to go to edit the code, you can't, okay, so say something wasn't right with your lead-in or lead-out. You're either cutting air or the tools come down on the part and kind of clipping it. If you were wanting to edit this, this would be an editing nightmare because you can't just change this number right here. You can't just change that to, instead of x 1.56 to x 1.55, because then the math wouldn't add up. So let's pull up paint. Alright, so you have a, let's just draw a rectangle. So you got your part right here. And if you have a radial lead-in, so your tool, here we'll make our tool path green. So the tool feeds in right here. Actually, let's use a brush. There we go. So your tool is going to lead in radially. Now if you have a circle, there's no circles in here. Got an oval. Okay. Okay, so you got to think of a GO2, GO3. Because it has a radial lead-in, you have to think of this as a circle with a center point. Okay, so you have to think of your X starting distance. So we'll say that this would be a GO3. Okay, so we'll just write this. Looks like a kindergartner wrote it. Okay, so you got GO3. So you would have to have your X starting point. I'll just put a dot right here. Your center point of the radius and your ending point. Okay, so you would have to calculate that. So if you just change this starting point right here, the math's not going to add up for the radius. So you have a I and K value right here. I'm going to let Garrett explain all that to you because that's, he's a CNC class. But you have your I, J, and Ks for GO2s and GO3s. If you just change this number, the math's not going to add up. There's going to be a conflict in the radius, your I and J values, and your starting point or ending point. So you can't just go here and change this number. I mean you could, but you would also, if you change this by 10 thousandths, you would also have to change this by 10 thousandths or this value by 10 thousandths. Okay, your starting points, or vice versa. If you're going to change the Y value, you'd have to change. There's going to be more to it. Okay, so that's kind of a pain. I mean, it's a really big pain because if you get something wrong, then the machine alarms out and it says invalid GO2 or GO3 radius value, and the machine won't do nothing, so you can't even run the part. So editing code at the machine with these GO2 and GO3 radial lead-ins, editing code is a I don't know, it's a nightmare trying to edit the code for that. Now you could do it, but it's going to take you some finesse mathematically. I mean, the math's simple, but you better be moving the math in the right direction. And sometimes it involves, you're taking 50 thousandths per pass. You would have to edit the code for each pass. Okay, so that you're going to spend 15 minutes trying to edit code when it would take you like 5 seconds to edit the code. Let's see. All right, guys. Let's take like a quick break. I gotta run to the bathroom. I don't know if anybody needs to take a quick break or something. I'm gonna do it, but I'll be right back. Okay. All right, so that was a simple version of the program using just a line. Oh yeah, hold on. So we still have the drill the hole right here. The hole size is 0.42 through hole. Let's look up what 0.42 is. So we're going to pull up the drill chart. I don't know what that is. Yes. Ye yes, yes. Yeah. Yeah, it's no problem. Okay, so we have a 0.42 diameter hole. So what we need to do is find what size drill that is, because the print says 0.42, that doesn't mean that, you know, the drills aren't labeled as diameter. They're labeled as you know, infraction values, or millimeter values, or lettered or number drills. So a 0.42. All right, so we have a 27/64 drill, which is 0.4219, or you have a 10.5 millimeter. Okay, so there is no drill that actually cuts it that size. All right. So the drill would be a little bit big. You know, the hole would be a little bit big. So you could just drill a 27/64 hole there, but it's a little bit big. Okay. Depending on the application of the part and the print dimensions or specs, you know, the customer may not want anything bigger than 0.42. Let's see, where was that? Yeah, you could. Yeah, so you could do. Where'd it go? Okay, so yeah, we'll go ahead and do that. Just for the fun of it. Okay, so we're gonna do it two different ways. The way I'm showing y'all right now is I'm trying to simplify how easy this actually is. Like, you don't have to have a 3D model. I want y'all to understand how CAD/CAM works in general, and not just Fusion 360. Because, you know, you may get a job somewhere and they're using Mastercam, right? And it's going to work different. And your boss might say, hey, I need you to write a program. And, you know, if you're used to doing everything in 3D, you might be making it way more complicated, you know? And you tell him you're stuck, and he's going to come look at the part, and you're like, dude, why are you drawing a 3D model? Just draw a line and a circle, okay? And if you're not used to seeing those type of toolpaths that are driven basically off a line and a circle, you know, it may confuse you. You might be like, what do you mean a line and a circle, okay? So I'm trying to show you all different ways to look at this. because it's good to be flexible. You know, you want to be like water. You know, whatever's thrown at you, you know, you kind of you know, you have the flexibility to figure it out. Okay. So anyways, just for this one part, I'm just gonna keep it simple and drill a hole. Then I'll draw the model up and show you how you're probably gonna do it in class. Okay, so what I'm gonna do is I'm gonna make a drill. Yeah. On this example, I'm gonna just drill a 27/64. But I'm doing this program twice basically. So, yeah. But I'm gonna do it. I'm gonna do exactly what you're talking about on the next example. Because this would actually work. I mean, you'd be 1/1000ths bigger. You know. I mean, but usually if it's just a through hole, usually 1/1000ths ain't gonna make a difference unless the print specs is requiring something more. Yeah. Okay, so on this example, I'm just going to drill the hole because that would totally work on this part. You don't actually have to get an end mill involved, but it would look something like this. So you come in, face it. And you come in and drill it. Alright, and you want to make sure, you know, the body of the drill is going through the stock. Alright, so that's that. And okay, so I'm gonna go ahead and delete these toolpaths because I really don't. I'm gonna move on to the other example of how to do it. Okay, so I'm just gonna delete everything and kind of start over here. Okay, so if I want to draw this part up in 3D, the way I would draw this is I have a 1.8 by 1.752 rectangle. So I usually like to put it on top view for mill parts. Okay, so I have that. Okay, so the overall part size is 0.623. So I'm gonna go to solid and extrude, and I'm gonna extrude this to be 0.63. Okay. Now I need to do the cut. I need to draw the cutout, right? So I'm gonna create a sketch, and be careful. Sometimes when you create sketch, it'll it'll flip your part sideways, your model sideways. So on this part, it looks like a square, but it's not. It's a rectangle. Okay. What I mean is, you know, your horizontal distance and your vertical distance is different. You know, they're not equal. So make sure you're, you know, when you create your next sketch, that it's doing the right distance. Okay, so it's 0.54 over, right? So I'm going to draw a rectangle right here, and I'm going to hit tab on my keyboard and go 0.54. Alright, I'm going to hit E for extrude, or for, you know, you don't have to use keyboard shortcuts. You can just go to solid and go to extrude. Alright, so I'm going to pull this down minus 0.265. Okay. Now notice I drew that in steps. I drew the rectangle body of my main part, right? But I didn't do the cutout. That's because you want to do it in stages. You know, you draw a body, and then you draw what would be a feature of that, and then you know you can cut it out or extrude it, and then you draw another feature. You know, so I drew. I'll back up a little bit. So I drew the main body, and then I created a sketch on top of it, and drew the dimensions of that cutout, and then extruded cut. And now I'll create another sketch on top of the part and draw my circle. So, and notice I'm not putting the circle in any particular place. I'm just kind of eyeballing it. I'm just going to get the main diameter, which is 0.42. Then I'm going to position it. So it's 0.516 over. So I'm going to go dimension, click here, 0.516. So I got my horizontal dimension. Now I need my vertical dimension, so 0.824. Alright, so now I'm going to go to solid, go to extrude. I'm going to click on that circle, and I'm doing a cutout, so I'm going to pull it down and through it, right? And even so, I see a lot of new Fusion 360 users, but what they'll just pull it down like this, like right here, and it'll hit OK. But the problem is they may have to go back because the cutout didn't go all the way through the part. All right, so I suggest exaggerating. Like anytime you're doing a cutout, just exaggerate. Just, you know, instead of trying to go to exact distance, like that takes time. Just go further down. I mean, it doesn't even matter how much you exaggerate. I mean, you're doing a cutout. It's a through hole, so you can go all the way down. I mean, you could do that. Just do it, you know, keep it quick and simple. Okay, so I have that, and that's the part right there. So this is how we draw it in Fusion. So I showed you all how to do it in 2D and 3D. Okay, it doesn't really matter. I mean, the only thing that really matters is keep it simple. What's the easiest route to go? You know, what does your boss want you to do? All right. Even sometimes your boss is going to want you to do something that may or may not be easier for you. Okay, it may make things easier for him, or sometimes he may not understand enough about CAD/CAM to make that decision. He may tell you to do it the hard way. Okay, and sometimes, I mean, if you can't convince him that there's a better way to do it, just do it the way he wants it done. I mean, sometimes your boss may not feel like jacking with it. He may just go get it done and do it the way he told you, you know, and just do that, you know. I mean, there's a time and place to argue with your boss, because sometimes they'll be wrong. And sometimes they'll think they're right, and sometimes they don't want to think about it. This is how it's been done, and it works that way, and keep doing it that way, you know. There's no, you know, in their mind, there's no sense in, you know, reinventing the wheel. I mean, don't break something if it's not, you know, don't fix something if it's not broken, you know. But anyways, so I have this right here. So now I'm gonna go to manufacturer mode, and alright, so now I'm gonna go to my setups. So I'm gonna create a setup. Now, one thing, when you're writing a program, it helps to know what side, you know. Let's see, let's pull up that link I shared with y'all. Yeah. Dude, they deleted my freaking post. Okay, so, man, that kind of makes me mad, dude. I spent 20 minutes writing that up. So I wrote, wait, hold up. Here it is right here. Well, it's still here. Okay. They said this this post is under investigation. I think it's because I named it compressor pin, and I didn't think about it, but that could be considered like a gun part or something. There's gun parts, you know. I think they thought it was something else, but they made it where it wasn't public anymore. That's kind of dumb. Anyways, I'll repost this. I'm kind of hesitant to post some of the Fusion 360 stuff on Lone Star, just because copyright law is kind of complicated, and the school is really big about like copyright stuff, you know. And you know, in all reality, Fusion 360 wouldn't really care, you know, but the school, they're kind of picky about what kind of pictures and images or videos you put on the website, because they're responsible, you know, by copyright law, they're responsible for all that. So this is like a blogging platform, and I was like, you know, I'll just post it on here, a link going here, you know, because I don't have to worry about copyright law, you know, for the school. Anyways, so anytime you're writing a CNC program, or you know, making a CAD/CAM file, you want to think you're trying to get from point A to point B. So point A is the stock material you're starting with, you know, the size and type of material, and point B is the finished product. So you want to get from point A to point B. So you want to think, you know, so basically, if we're writing a program, you kind of need to know, you kind of have to know what the stock size is going to be. I don't know if y'all have 5/8 material, but let's see. You know what? I have a list of stock material that we have at the school. Let me pull this up. Because we're gonna write the real program. I don't want to write it like a pretend program. That's not really going to work. Because sometimes in class, in order for me to show you how everything works, you know, I write programs, but there's some iffy stuff about the program. Like, you know, you have to know what the stock size is. Okay, so this is the different stock sizes we have at the school. We have 3" by 3/8, 2" by 3/8, 2" by 1". Now this was a year ago, so I don't know what the school has now, but we're gonna write the program to make it more flexible. What I'm getting at is, what we'll do is, because this is 5/8, you're probably going to use 1" stock. Okay, I'm not really sure what Garrett has in mind, but we'll just assume we're going to have 1" stock. So what I'll do first is, we'll get our orientation right. So, oops, that wasn't right. Yes. Yeah, well, what you would have to do is you can't edge find the middle of the part, so you would have to, you would have to do the side of the part, and then measure the part and divide by 2, and then offset that distance. You know what I mean? That's why I always, on square or rectangular parts, I always put in the middle. But I think Garrett does it I always put in the corner. I think Garrett does it in the middle. That's because when y'all first start learning it, the Cartesian coordinates, it's helpful to put in the middle. But when you actually start making parts, you really want to put it in the corner. Mm-hmm. Oh yeah. Yeah, so I'm gonna put the origin, like, man, why is it? I'm gonna put the origin right here. Okay. Now, because there's a good possibility you are gonna face the top of the part and then cut this, what I'm gonna do is, here, we'll name this op 1. There could possibly be another operation. Okay. I'll show y'all some different ways to do this. Garrett may have something else in mind, and I just thought of what he might want y'all to do, but I'm gonna go ahead and show y'all this way. So I have everything set up, but there's a good possibility we're gonna have to face it down because it's gonna finish at 5/8. So what I'm gonna do is I'm gonna go to face, select the tool, and that's gonna be our face. But okay, so the finished part is gonna be 0.63 tall, and I'm just thinking there's a possibility he's gonna use 1" material, so you would have to face it down. So I'm gonna go 1" minus 0.63. Okay, and we'll make this. Okay, so that's taking it in one pass. You probably want to take it in a few passes. I'll go multiple depths. Let's do 0.05. Okay, so I have something like this. This is assuming that the material is tall. You know, that you're going to saw a piece that's 1". So it looks something like this. And it wouldn't really be cutting air. Well, if you didn't have to face anything off of it, it would be. Oh, what did I do that for? Okay, so you'd face it like that. And then we'll do a 2D contour. So Garrett said he had a 3/8 end mill, so what I'm going to do is I'm going to click on this is the document, Advanced 201M. That's, you know, whatever the print says in the title block, that's what I name the documents. You know, I saved the file named that. So I'm going to create a end mill for this project, and we're going to say it's just a regular flat end mill. I'm going to name it 3/8 inch end mill. I'll go to this tab, make it 3/8. Cutting data. I know Garrett, that mill goes pretty fast. I think Garrett likes to open it up, go fast as possible. We'll just go 3500. I'm not sure what kind of end mills he has. Hopefully it's a 2-fluter. And you could go a lot faster on these feed rates. I like to start off slow on the feed rate, and then at the machine, basically you go to run it. I usually start off like 15 inches per minute on my feed rate. And then on the machine, I'll override the feed rate, keep going faster and faster, and see how far I can push it. You basically have to watch how the shavings come off the part. You know, you want nice C shapes, and you want to listen to it. If it starts rattling a lot, you know, you may want to slow down the feed rate. But once you get a feed rate that's working good and it's not breaking tools, or you know, you're not burning up end mills, then you go back to the cam software and enter that feed rate that's working better. Alright, so I have a 3/8 end mill. My contour section, so I'm gonna drive it off this line. Now notice it wants to select that whole chain. That, you know, I want to select just this one line. So I'm gonna hold my Alt key down on the keyboard. I'm gonna select that. All right, and make sure your arrows, make sure it's on the right side. Okay, because that's the side you're cutting on. My height tab. The only thing, I'm gonna keep it simple. I actually go through here and change these to reflect, basically to minimize cycle time. But you guys at the school, let's just keep it simple for now for this project. I'm just gonna tell it how deep I'm going. So I can put it on selection and click here and just tell it I'm cutting down to here. All right. I'm just gonna hit OK. And this is the toolpath it gives me. Now this toolpath, there's issues with that, and that's because I'm using a 3/8 end mill, and this flat is wider than 3/8, right? So it doesn't cut everything. So what I'm gonna have to do is on my passes, I'm gonna have to put it on. I'm gonna have to add rough passes, and we'll say 3 passes. That might be a little bit much, because this first pass at 3 is going to be cutting air, so it's not even touching anything. So in that case, you know, you don't want to be cutting air, because you're going to look like a newbie, which is nothing wrong with that. I mean, if you're new, you're new. So now I have something that looks like this. So I have that. Now this is a .42 hole. Here, let's just name this side cut. Alright, so alright, so you have to think, what drill sizes do y'all most likely have? The most common drill sizes is like 1/8 inch, quarter, 3/8, 1/2 inch, 5/8, 3/4, 1 inch. They usually go in fractional, like simple fractional increments. You know, like 27/64s. You know, a machine shop will probably have that drill size, but the school, there's a good chance they won't. Okay, they're probably gonna have like the basics. So the size smaller from .42, like the basic size that's most readily available, is a 3/8 drill. So I'm gonna select a 3/8 drill. So I'm gonna go to, in my tool library, I'm gonna select on the document, or you can just add it to the library. I like to select the document, and I'm gonna click this plus sign, and I'm gonna go to drill. I'll name this 3/8 drill, and I'm gonna change the cutter, 0.375. Everything else I'm not worried about, because you gotta think, it gives you a lot of stuff you could change, but there's only like 3 parameters you really need to change. You know, name it so you know what it is. You know, the cutter diameter and the tool number. Okay, that's the main stuff. You could just change that and be done with it. I don't mean, I've never once went to the shaft or holder tab and changed anything. Not on Fusion. But we'll do the RPM. So I'm gonna go 1200. You know what? Let's just go faster. Now we're cutting aluminum, so we get 1800. Plunge feed rate 4 inches a minute. That's good. So I'm gonna hit accept and go ahead and select that. Geometry, so I'm gonna select the hole and the height. The only thing, just to keep it simple, I'm just gonna make sure it's on the hole bottom. Yeah, but if I hit OK, how it is, the drill doesn't, it goes to the bottom, but we want the body of the drill to go to the bottom, because then you would have this extra material here, right? So make sure when you're telling it the depth on the height tab, your bottom height, make sure you put it on drill tip through bottom, and always go a little extra, like extra 50 thousandths. You know, that's on through holes. If it's a blind hole, you better go, you know, it better be the right depth according to the print. Okay, so I have this, and we still have a little bit of material left to cut out, right? So I'm gonna rename this 3/8 drill, and now we need to cut out the rest of this material. So in order to do that, I could either use 2D Pocket or 2D Contour. It doesn't really matter. Well, it does. 2D Contour is probably better because it gives us ability to put a compensation in here, a wear compensation. So say this hole came out a little bit small, on the machine you could compensate for it. Okay. But anyways, so here I'm gonna use that 3/8 end mill. And what I'm going to do, I'm going to select the hole, the height, I'm just going to put it on model bottom, but we'll go extra 50 thousandths deep. to make sure, you know, it'll help minimize a burr right there. And I would take multiple depths. Now, because we already removed most of the material and we're just kind of finishing it, I would go like I would go like 0.25, okay, because we're not really cutting out much material off. And coffin, I would make sure to put a wear in there, and I would also, for lead in and lead out, I would select, because we pre-drilled it, I would select a pre-drill position so it drops in the middle of that hole instead of the, you know, on the side of it. And let's hit OK, see what it gives us. Alright, so then it gives a toolpath. We have our drill, but there was some kind of conflict in the 2D contour. Let me show you what happened. So if you go to the link, I did pre-drill, but the hole size is 0.42. Okay, so if I pull up a calculator right here, all right, so our hole size is 0.42. Now our end mill is 3/8. So if I subtract that, we only have 45 thousandths of material, but that's diameter value per side of the part. We'll take that, divide by 2. We only have 22.5 thousandths of room, you know, because if you drop a 3/8 end mill in the middle of that hole, you only have 22.5 per side distance to go. Now, if these lead-ins right here are a greater value than this distance, you're gonna have a conflict. So I'm just gonna put this at 0. My lead-in angle, put it at 0. This distance has to be smaller than 22.5. I'm gonna put it at 0.01. Well, yeah, I put it at 0.01. Now it still didn't give me a toolpath here, so let's see what else happened. It's a clearance issue somewhere. It could be, there's a couple of spots. Sometimes it's this compensation radius allowed. You usually have problems. A lot of times it won't give you a toolpath if there's some kind of conflict, and it give you a number of things. What is it? I forgot where it is. Here, let's put that at 0.01. Okay, it doesn't like that. Here, let's make this value smaller. I think it's 4. Oh man, I forgot. Yeah, I don't know why it's not liking that. Here, let's look at our warnings. Oh, okay. Let's see what's going on. Because the drill hole is 3/8 and the end mill size is 3/8. Man, it shouldn't add a collision. Here, we'll just put it on ramp. Sometimes when this happens, if you just put it on ramp, it works out fine. Yeah, we'll clear this out. And this usually happens when anytime that you're dropping an end mill into a feature where you don't have much clearance. Sometimes you have to fiddle with your lead in and lead out distance or the type of lead in. Like this maximum ramp stay down. Also, sometimes it's the starting point too. If we're here, if you're doing a 2-degree lead-in, okay, so it's giving me a problem. To be honest, I could probably sit here and fiddle around with this, but y'all probably gonna have problems too. Instead of a 2D condor, we'll just use a 2D pocket. Okay, so I'm still going to use everything's still going to be the same. This is my pocket, my height tab. You know, we'll put it on stock bottom. We'll go a little deeper right here, and we won't leave any stock for finish because we kind of already done that by drilling it. Like there isn't enough stock there. Let's just hit okay, see what it does. Alright, that's the drill. It still didn't give us a toolpath. Hold on, let me measure this. 0.42. And we're using a 3/8 end mill. Let's check the diameter, make sure it's really 3/8. Because it doesn't like that. Cutter diameter, yeah, it's 3/8. And we'll put it on multiple depths. Alright, so what's probably conflicting right here is this maximum step over. So if you're going to step over 0.3562, as you can see, like in the illustration, you know, when you take a pass, it's going to step over 0.3562, right? Now, think about this. If you only have 22.5 thousandths clearance per side, if you have a 0.42 hole minus 22.5, you can only possibly step over 0.397. So that should actually get it, but we could increase this. Yeah, you wouldn't want to step over more than 0.397. Hold on, let's just put this at 375. Okay. Now these lead-ins are giving us trouble. anytime that you have just a little bit of clearance, you know, you're dropping an end mill into a feature that there's like, you know, the end mill is like just a little bit smaller than in the future, like the hole or whatever. It's good to get rid of these lead in lead outs and actually use like a ramp, like either a helix, but you have to change this helical ramp diameter. This is your maximum diameter. We'll say 0.375.
Somebody's at the door and they keep pounding on it.
Okay.
And they can't open it.
Okay. Hold on. This should do it right there. Okay, so I put it on pocket, and